Hi everyone, my name is Grokhotkov. I'm VP of Software Platforms at Espressif. Welcome to Espressif DevCon25. Since our last developer conference, we've been busy on many fronts, launching new products, releasing new versions of software, improving security, and expanding the ecosystem. Let me give you an update on our progress, starting with the chips. Over the past year, 3 new SoCs have gone into mass production. First, the ESP32P4, our high-performance microcontroller with dual-core RISC-V processor running at up to 400 MHz. ESP32P4 is aimed at HMI applications, edge computing, and any application that requires rich I/O. Support for ESP32P4 is already available across our SDKs and frameworks, including features such as hardware-accelerated H.264 encoding, graphics acceleration, and offloaded Wi-Fi connectivity using chips such as ESP32C6. Next, the ESP32C5. It's the industry's first RISC-V SoC with Wi-Fi 6 on both 2.4 and 5 GHz bands, plus Bluetooth 5 and IEEE 802.15.4 for Thread and Zigbee. ESP32C5 is a great option for multi-protocol, low-latency applications. It also supports external PSRAM, which allows for more feature-rich applications and gives more breathing room for future software upgrades. And third, there is the ESP32C61, which brings affordable Wi-Fi 6 and Bluetooth 5 connectivity, again with optional external PSRAM. It's designed for cost-sensitive products that do require large amounts of RAM. Now, let's take a look at what is coming next. The ESP32H4 is our next generation low-power SoC with 802.15.4 and Bluetooth 5.4 LE. Compared to Bluetooth 5.0, it offers much lower power consumption and unlocks new use cases such as LE audio, PAWR, and direction finding. The ESP32H21 is a low-power variant of the H2. It is aimed at battery-powered sensors and small devices that rely on 802.15.4 and Bluetooth LE. And finally, our first Wi-Fi 6E product. It supports 6 GHz band, 160 MHz channels, and runs as a 2x2 MIMO multi-protocol transceiver. It's built for high throughput and low latency. This is also our first product with Bluetooth LE 6.0 and BR EDR support. On the security side, we've also made good progress. The ESP32C3, S3, and H2 have all received PSA Level 1 certification. The C6 became the industry's first RISC-V MCU to achieve PSA Level 2, which is a big milestone for our affordable security goal. With ESP-TEE, we now isolate crypto operations inside a secure environment. TE stands for Trusted Execution Environment, which helps with secure Matter integrations and generally raises the security baseline for connected devices. We also published detailed RED-DA compliance guidance, including a self-assessment tool to help customers meet the new European wireless regulations with less guesswork. In parallel, we've been investing a lot of time into improving the developer experience, both for application developers and for people who build reusable components. In ESP-IDF 6.0, our next major release, we are introducing, for example, a new version of the CMake-based build system. It's more flexible, it integrates better with standard CMake projects, and makes third-party code reuse much easier. In this build system, the component dependencies can now depend on kconfig options, which opens the door to more modular and more configurable designs. Our component registry has grown to host over 1,000 components. It now also provides the MCP server, so coding agents and other AI tools can automatically find and pull the components based on the project needs. We've also been working on ESP-IDF installation process, which historically has been inconsistent between command line tools, Windows installers, and IDE plugins. We are consolidating everything into a single tool called ESP-IDF Installation Manager, and we are updating the documentation and ID integrations to use this unified workflow. Inside the ESP-IDF and the registry, we continue to add new building blocks for more complex IoT applications. For example, we made updates to our USB driver framework. We added new secure DNS and Ethernet driver components, improved 4G modem support, and added many new core features like binary format logging and over-the-air updates for the bootloader. This is just a small portion of the new features that we've developed during the last year, and we will share many more during the DevCon. For Matter products, our ESP Matter SDK is now Matter 1.4 ready, and work on Matter 1.5 is underway. Matter 1.5 adds new clusters and new device types, including cameras, and we support those. We also have our Rainmaker camera solution, which gives developers another way to build secure cloud-connected video products. Based on the feedback we got from our ESP Zero Code solution, we are addressing the needs of device makers who want a fast way to get a working Matter product, but require more customization than Zero Code can provide. So we are introducing ESP Low Code framework for building production-ready Matter devices. There is a full talk about this later in the conference. We are also releasing the ESP Rainmaker App Development Kit. It's a TypeScript-based toolchain for building hybrid iOS and Android apps that integrate with Rainmaker Cloud. The goal is to make app development for connected products faster and more predictable. On the multimedia side, ESP GMF and our UI framework Brooksia have both matured a lot, and they now allow for more advanced, visually rich applications on the ESP32S3 and the ESP32P4. Alongside of all this, our existing co-processor solutions such as ESP-hosted, ESP-AT, ExpressLink, and ThreadRCP continue to fill important roles for customers who prefer a hosted or a modular design. We are also actively working with other ecosystems. We have released the version 1.0 of ESP Hall, which is the first official SDK for embedded development in Rust language offered by a chip vendor. ESP32C6 support is now upstream in Zephyr, and work on ESP32P4 in Zephyr is ongoing. Our Arduino releases stay aligned with ESP-IDF chip support, meaning that new targets such as ESP32P4 and ESP32C5 can also be used by Arduino developers. We also continue to improve support of our new chips on NuttX, and thanks to NuttX's strong POSIX layer, we even have full CPython interpreter running on Espressif hardware. Earlier this year, we introduced our documentation chatbot, which gives authoritative answers directly from our docs. It has already served more than 100,000 queries, and it's quickly become the first stop for many developers when they have a question. Speaking of documentation, we have launched the new documentation website, documentation.espressif.com, also known as CDP. There, you can find datasheets of chips and modules, technical reference manuals, user guides ranging from developer boards to software packages, as well as product documents such as certificates, advisories, and PCNs. We have also published over 60 articles at our developer portal, developer.espressif.com. Over at the developer portal, we are not only announcing new releases, but we are also sharing tutorials, practical guides, and even workshops. Another notable thing that happens since our last DevCon is the increase in the capabilities of AI coding agents. In many practical cases, we see that tools such as GitHub Copilot, Claude Code, and Cursor can greatly help developers in their work. When writing code for Espressif chips, AI agents perform quite well thanks to the large number of open source projects written for Arduino and ESP-IDF published online. Now that these tools and IDEs combine LLMs with access to project codebase and the development tools, complete end-to-end workflows become possible, including developing new features, increasing test coverage, doing refactorings and bug fixes. Since most of the functionality of our SDKs and frameworks is available in the form of CLI commands, compiling, flashing, running unit tests, agents are already capable of helping you with many development tasks. On top of that, we are building MCP servers to help integrate the SDKs, tools, examples, and documentation better into these workflows, improving the results. We are also working on something new in the area of AI agents. It will help customers build simple voice interactive systems, app-based customer support tools, and agents that bring intelligence into connected devices. We will share more on this soon. All of these efforts make developing with Espressif hardware faster, easier, and more powerful than ever before. Our goal is to provide affordable, secure connectivity for everyone. We are proud of what we've built, and we are even more excited about what comes next. Thank you all for being part of our developer conference, and I hope that you enjoy the event.